Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Ms. Ledwell, and in this video, we'll discuss writing formulas for binary ionic compounds. Let's begin. Recall that when elements form ionic compounds, electrons are transferred from metal atoms to nonmetal atoms. The oppositely charged ions attract one another until the charges balance out, and the overall ionic compound is electrically neutral. It has no charge. This means the positive charges on the metal ions must equal the negative charges on the nonmetal ions. In other words, the sum of the charges must be zero. For example, the binary ionic compound magnesium fluoride, we see that magnesium has two positive charges, and in order to have two negative charges, we need to have two fluoride ions because the fluoride ions have one negative charge each. This will balance out then because we have two positive charges coming from magnesium, and together our two fluoride ions give us two negative charges. Overall, the compound is electrically neutral, has no charge. Let's look at aluminum chloride as an example. The ion for aluminum has three positive charges, and the chloride ion has a negative charge. So we have one aluminum ion with a charge of positive 3, and we have three chloride ions each with a charge of negative 1. 1 times positive 3 for our aluminum ions gives us positive 3, and 3 times negative 1 for our chloride ions gives us negative 3. The net charge is 0 and balanced out. Let's look at another example. This time we'll look at calcium phosphide. The ion for calcium has two positive charges, and the phosphide ion has three negative charges. We can see from our formula we have three calcium ions, each with a charge of positive 2, and we have two phosphide ions, each with a charge of negative 3. So looking at our calcium ions, 3 calcium ions times a charge of positive 2 each gives us an overall positive 6 charge on our calcium ions. And for our phosphide ions, 2 phosphide ions with a charge of negative 3 each gives us an overall charge on our phosphide ions of negative 6. The net charge is 0 and balances out. For the main groups in the periodic table, the charge of the ion depends on the group number. There's a pattern to the charges. Group number 1, the alkali metals like sodium and potassium, have a charge of positive 1. Group number 2, the alkaline earth metals like magnesium and calcium, have a charge of positive 2. In the middle of the periodic table, we have groups 3 to 12. These are the transition metals. Most transition metals have more than one possible charge. They are called multivalent metals. We will be talking about these in another video. Group 13 have a charge of positive 3. Group 15 have a charge of negative 3. Group 16 elements have a charge of negative 2. Group 17, the halogens, like chlorine, fluorine, and bromine, have a charge of negative 1. And Group 18, the noble gases, have no charge. Now we will pause this video and watch the video Finding the Charges of Ions on the Periodic Table embedded in Brightspace to learn more about finding the charges for ions. After you've watched that video, resume this instructional video and we'll continue our lesson. Now we'll look at the steps you need to take to write the formulas for binary ionic compounds. Our first step is to analyze the chemical name provided to identify the elements involved. Next, we will write the symbol of the metal cation along with its charge, followed by the symbol of the nonmetal anion and its charge. Let's look at some examples. Our first example is a binary ionic compound, beryllium fluoride. Our cation is the metal beryllium, and it has a charge of positive 2. You can remember that beryllium is an alkaline earth metal found in group 2 of the periodic table and therefore has a charge of positive 2, or you can look it up on a periodic table with the ionic charges listed. Our anion is fluoride, and it has a charge of negative 1. Again, you can remember from the group number or you can look it up on a periodic table that lists the charges. For calcium sulfide, our cation is calcium with a charge of +2, and our anion is sulfide with a charge of -2. Sodium nitride, our cation is sodium with a charge of +1, and nitride is our anion with a charge of -3. Potassium chloride, potassium is our cation with a charge of +1, and chlorides are anion with a charge of -1. Magnesium fluoride, we have magnesium as our cation with a charge of +2, and our anion is fluoride with a charge of -1. For our next step, you need to determine how many positive ions and negative ions are needed to make the overall charge 0. In other words, you're balancing the positive charges with the negative charges so that the ionic compound has no net electric charge. Let's look at magnesium fluoride as an example. So our magnesium ion has +2 charge, and our fluoride ion has a -1 charge. In order to balance these charges out, we're going to need one magnesium ion, so 1 times +2 will give us an overall charge of +2, but we're going to need 2 fluoride ions. 2 times -1 will give us an overall charge of -2. So we have +2 overall charge for our magnesium ion and a -2 overall charge for our fluoride ions. That will balance with an overall charge of 0. Our third step is to use subscripts to write the formula. For example, for magnesium fluoride, we said that we would need 1 magnesium ion, and note that there will be 1 magnesium, but we do not write the subscript if it is 1. We would just write Mg. And then for fluoride, we said that we would have 2 fluoride ions because 2 times -1 would give us the charge of -2 we needed to balance out the charges. So there will be 2 fluoride ions. 2 will be our subscript for fluoride. The formula then for magnesium fluoride is MgF2. Note that we do not include the charges of the ions in the formula. We only use those for balancing purposes. Now we'll pause this video and watch the video writing formulas for ionic compounds, which is embedded in Brightspace. After watching that video, please resume this instructional video and we'll continue our lesson. Next, we'll look at the crisscross method for balancing ionic charges. Our first step is to write the symbols of the elements, the metal first, followed by the nonmetal. For example, for sodium nitride, we would write the symbol for sodium, Na, followed by the symbol for nitrogen, which is N. Step 2 is to add the ionic charge for the ions. For sodium nitrate, we would add a positive charge to our sodium and a -3 charge to our nitrogen. You can look these charges up on a periodic table of elements that includes the ionic charges. Step 3 is to crisscross the charges. The number from one ion becomes the subscript for the other ion, and vice versa. For example, we take the positive charge with our sodium and write it underneath nitrogen, and we take the -3 charge with our nitrogen and write it underneath sodium. So sodium then is going to have a subscript of 3, the number underneath sodium, and nitrogen has a 1 underneath it, but remember we don't write the subscript 1. So finally, we rewrite the formula without the charges, and we don't include the subscript of 1. So the formula for sodium nitride is Na3N. Let's look at one more example. Step 1 is to write the symbols of the elements, the metal first, followed by the nonmetal. For example, for calcium phosphide, I'm going to write the symbol for calcium, Ca, and for phosphorus, which is P. Now I'll add the ionic charges for the ions. For example, calcium has a charge of +2, and phosphide has a charge of -3. Now I will crisscross the charges. The number from one ion becomes the subscript for the other, and vice versa. For example, I'm going to write the 2 from calcium underneath the phosphide ion, and I'm going to write the 3 from the phosphide ion underneath calcium. So when I write my subscripts, calcium will have a subscript of 3, and phosphorus will have a subscript of 2. Finally, I'll rewrite the formula without the charges. So the formula for calcium phosphide is Ca3P2. Now it's time to review. Complete the learning activities for this lesson in Brightspace.